Let me also share the slides. Okay, so today is February 23rd, 2022. This is the Kubernetes data protection working group meeting. I think today, then maybe we'll just give a high-level overview of NetApp's volume replication, and then in the next meeting, he will have some slides and go through that in detail. Okay, so Ben, it's all yours.
Yeah, hopefully it'll be next meeting. I have so many different things going on.
Oh, that's fine.
So yeah, the high-level sketch of how Trident does volume replication is you can indicate when you're provisioning a PVC that you want it to be mirrorable, and that will basically prevent it from ending up in a system where we can't perform mirroring. But other than that, it's an ordinary PVC. You can take snapshots of it, you can do all the normal things, and by default, it's not actually mirrored. And then when you want to establish a mirroring relationship, what you do is you create a special CRD that points at that PVC in the same namespace. So your admin has to give you, RBAC access to create Trident mirror relationship CRs. So there's access control around who can do this, but you create a Trident mirror relationship CR on the original PVC, and it dumps back some specific details that are needed to create the secondary, because there's some internal names that are necessary on the other side to establish the mirror relationship. And so the controller will populate those names into the CR. And then you can create a secondary PVC on either the same Kubernetes cluster or a different Kubernetes cluster, or pointed at the same storage controller or a different storage controller. It's quite flexible. And there is a prerequisite that if it's a separate storage controller, that a peering relationship has been established out of band between the two storage controllers, so they can talk to each other and they know about the existence of each other, and all the networking is set up. But then you can just create a second PVC on a second system with another Trident mirror relationship CR, and Trident will create the secondary volume, and it will establish a mirror relationship, and the volume will then just be mirrored. So you'll have an existing volume that is a copy of the primary volume, and it will be nominally writable. So like, your PVC can be, RWO, RWX, whatever you set, but in actuality, if you attach it to a pod, you won't be able to write to it because it's the destination of a mirror relationship. So, so that's a little bit of a lie, but it's important because later, if there's an actual disaster and you want to start using the secondary volume, then you just mutate the Trident mirror relationship CR to break the relationship, and you can attach a pod to the secondary PVC, and it will become immediately usable as soon as the relationship is broken. And then if later on you decide you want to reestablish the relationship in the reverse direction, again, that's just you make another change to the Trident mirror relationship CR, and we will reestablish the relationship in the opposite direction. Or you can, if the primary is gone, if the disaster was a real disaster and you actually lost the volume, then you can just go create another PVC in another place and establish a new mirror relationship, and it will start mirroring to that new place. And the other thing that we thought was important when we designed this feature was the ability to do planned failovers. In particular, planned failovers that are lossless, because in an actual disaster, you expect to lose some data. There was a disaster, but when you're testing your failover, it's important that you can, switch from one site to another without actually losing any data, so that you can. So it's the kind of thing that you're encouraged to do frequently, like as a monthly test. So what we do there is you can establish a snapshot, and then there's a special, I'm trying to remember the name of our special snapshot CR. I think it's called like snapshot info. It's a weird name, but you can take a snapshot of your primary volume. You can create a snapshot info CR, and it will give you the internal name of the snapshot. And then you can break the relationship on the secondary side with an indication to wait for that snapshot to be transferred. So, you can shut down your primary application when it's shut down, or quiesce it, however you do your consistent snapshots. You can take the snapshot on the primary, you can obtain the name of it, and then you can tell the secondary, as soon as you have this snapshot, break the relationship and bring up the volume. And then you can start your application running on the secondary side, and it's guaranteed to have a consistent view of the volume as of the snapshot that you took on the primary. So that allows you to.
Question, when you say transfer, what do you mean here by transfer the snapshot?
Yeah, so NetApp has multiple mirroring technologies down at the software layer or at the storage controller layer. We have asynchronous flavors of mirroring, where basically you just take a snapshot every few minutes and then transfer the snapshot. We have synchronous forms of mirroring, where every single write is mirrored and acknowledged on the secondary before we acknowledge back to the client. And in both cases, you end up, all of the snapshots that get taken on the primary also appear on the secondary. And they don't show up as
so the transfer,
Kubernetes.
it will be replicated to the second. That's what you mean. It's not, because when I hear transfer, I was thinking about namespace transfer, but that's not what you mean. It's basically
no. Yeah, I mean, the snapshots get replicated from one volume to another volume.
Okay.
And they don't show up in Kubernetes because we don't have a way to import existing snapshots, but they're there on the storage controller, and you can tell the storage device it needs to only break the relationship after it has a particular snapshot, so that you can effect a lossless failover from your primary to your secondary and then reestablish the relationship backwards, which is what we would encourage someone who wanted to test their DR workflow to actually do on a regular basis, right? Because if you don't test your DR workflow, it's never going to work in an actual disaster. So so the lossless failover is something that we felt was very important. There are other flavors of this. So you can control whether it's asynchronous or synchronous, or we have various flavors of synchronous. Like synchronous mirroring gets very complicated because you pay a performance penalty when you enable it, right? Because the client application that's actually writing data can't see an acknowledgement to its write until it has been replicated on both sides. Otherwise, it's not really synchronous. So there's various games that we play to try to make it as performant as possible while maintaining there's different levels of synchronous guarantees in terms of what you're going to get in the case of a failure. But and I won't go into all the different flavors of synchronous, but the point is that you can just, these are just options you select in when you create your try to mirror relationship, what type of mirror relationship you want to get, and then
you said that you cannot import them, but since you know the snapshot handle, then you can create a volume snapshot content to use it, right? You cannot?
Not with Trident, no, we don't allow that. Yeah, someday
is that generally available? Is that only because you have replication that's not available? What if, like, in general, do you support?
It's because Trident has snapshot metadata internally that if you don't recreate it, you won't get you can't just create a volume snapshot content object and a volume snapshot object and point it at Trident.
But then how do you prevent people from using that? Because if someone just create a volume snapshot content and just point to an existing snapshot handle, does that automatically?
Because the handle would be invalid. You wouldn't have a
so
string.
You basically, it's going to fail because the snapshot list snapshots will fail or something like that. Because it's going to, you support the list snapshots, right?
I think we only support the singleton version of list snapshots. I don't think we actually support listing.
That's fine. But then basically because I was just trying to think about like the snapshot, what snapshot controller would do, right? It's going to try to validate that. Then it's going to get back from Trident that snapshot does not exist, basically.
Right. So the point is Trident has to know about the snapshot before it will acknowledge it back to Kubernetes. And so even if it exists on the storage, that's not enough. And this is just a missing feature in Trident.
Okay.
We totally plan on adding snapshot import. It just hasn't been a priority.
Because I was just thinking that some backup software would be relying on that. I was just wondering if that's
well, so backups typically are based on snapshots. So we see backing up and mirroring as like two, I don't want to say orthogonal because there's significant overlap, but there's two different use cases, right? Backing up is typically about the ability to go back in time to an earlier version of your data, right? That's usually why you have backups, unless you're also using backups as a disaster recovery mechanism. For disaster recovery, what you really want is the ability to have the most recent possible copy of your data no matter what happens, right? So a backup solution can offer you both of those features, but we typically view them as separate. Snapshots are about going back in time. Mirroring is about having more copies of your data so it's more resilient, and you can use them both together, but they're separate use cases.
Right. What I was trying to say, like a lot of the backup software will actually rely on that static provisioning because it just looks like it's not going to work in this case. Just like a regular snapshot. They take a snapshot and then they.
Well, the snapshot on the system where it's taken, Trident knows about it, and you can use it.
Oh,
like
you
an
can
ordinary snapshot.
But you can do static provisioning. You can create another
on the
snapshot content.
If it's on the same Kubernetes cluster where the snapshot was created.
Oh,
then,
that will.
then
okay.
Yes.
So okay, I see. So that's okay. That's all. Yeah. Then that would work.
But this mirroring solution is particularly designed for going cross Kubernetes clusters. So you have Trident running on cluster A at one site, Trident running on cluster B at another site. The storage controllers underneath know about each other, but the Kubernetes clusters don't necessarily know about each other, right? Kubernetes clusters and Kubernetes federation is still sort of nascent, and we're not relying on it. We merely rely on the storage controllers knowing about each other and somebody transferring those internal handles from one cluster to the other. It's just a string. So you create a volume on one side, you get the volume name and the SVM name, and then you go to the other side and you plug those two values back in and you create another PVC, and then magic happens and you get a mirror. But the two Tridents never talk directly to each other. Trident never knows about anything outside the cluster it's in. So all of the magic happens down at the storage layer.
Trident here. Trident here is the CSI.
Trident is NetApp CSI provisioner and many more things. I mean, Trident sort of predates CSI, and as CSI was invented, we of course support it, fully. But Trident has a lot of other, controllers and functionality built into it, in addition to just being a CSI driver.
All right. So Trident's restricted to Kubernetes control plane in terms of its.
Yes. Trident
which is why you said Trident doesn't.
Yeah, it intentionally never spans outside of a Kubernetes cluster. So we have other software that spans Kubernetes clusters, but Trident is has blinders on to, it just knows about the cluster that it's in.
Got it. Thanks.
I wish I could walk through some more detailed examples and show you exactly how it works, or even demo it. But like I said, that's going to require prep time and setting up a demo environment, and I don't have those available today.
So at the heart of the system, is it a static PV that's created to recover on the secondary site?
No. So that was the important thing to understand is we actually have PVCs for both the primary and secondary. And so when you want to break a relationship and recover from a disaster, and I'm doing air quotes that you can't see, then the PVC is already there. It just has to become writable. And so there's this, you trigger the failover by mutating the Trident mirror relationship object, and then the status gets updated once the relationship is broken. And at that point, any pod that's attached to the volume will be able to start writing.
Okay, so broadly, PVCs exist on primary and secondary, are coupled with a Trident mirror object resource on primary and secondary.
Yeah.
Secondary is readable only till the Trident resource object, mirror resource object is updated as primary, or however the spec is.
Yeah,
ongoing.
yeah.
Okay,
What
so
really
that,
matters is that the relationship down at the bottom is broken, and the storage controller makes it writable. Because as long as it's the destination of a relationship, it's not going to be writable. Because all the writes
right,
are coming across the mirror relationship rather than from real clients.
right. So if two PVCs are created independently on primary and secondary, the Trident mirror resource requires the handle of the PVC from the primary on the secondary and vice versa.
Yeah, in order to you establish the relationship on the secondary with information gleaned from the primary.
Got it.
And then
Okay.
Trident will just set it up. And Trident can reestablish a previously broken relationship without transferring all the data. If it can find a common snapshot that both volumes have, then it will resync from that point. And that can dramatically speed up a resync if you just had like a temporary disruption.
Does Trident do that, or the underlying replication engine?
It's Snap Mirror down at the bottom.
Yes, Snap Mirror does
that work? Yes.
Yeah.
Does NetApp have the concept of stretched storage cluster, where it's a single storage cluster connected to Kubernetes?
Yes, it does. But this particular Trident mirroring feature doesn't apply to that case. Because in that case, it just looks like one cluster to us, and the volumes are just ordinary volumes.
Correct. So in that case, how do you do replication between the two clusters? Kubernetes cluster. I'm failing over, when I'm failing over an app from one Kubernetes cluster to another Kubernetes cluster. You
mean two different clusters where they're actually pointed at the same storage?
Yeah.
Like, yeah. So that would just be like an ordinary volume import case, right? Because the volume is already there. It already has your data. It's just the other Trident doesn't know about it. So you just do a volume import, and then the Trident knows about it, and then you can use it.
Yeah, if it is the same storage backend, storage cluster, you can also clone your volumes instead of doing replication, and you can achieve the same and import the clone.
Yeah.
So Ben, back to the, yeah, go ahead.
Yeah, but if they are different kube clusters, then the clone source needs a PVC, right? So you still need to know from cluster A what
you have to import something. You can import the original PVC and then clone that, or you can perform the clone on the original cluster and then import the result of that, or you can clone it outside of Kubernetes and then import that. There's a variety of ways to do it.
Right. The import's the point. There has to be an import phase to however you do it.
Right. And that's because we don't let Trident talk outside the cluster to other Tridents or other Kubernetes clusters.
So
yeah,
yeah, go
model is pretty similar. So I do understand why you don't want it. I don't think we should do that from a storage controller perspective, but yeah.
What don't you think we should do?
Shouldn't do. So Trident talking to Trident, or CSI controller talking to CSI controller. I don't think.
Well, that's just, there's no reason that you can't do that. It's just we decided that would be too hard to maintain, too hard to support, and we'd rather have a modular architecture where the Trident is the thing that doesn't know what's going on outside the cluster, and that there's another layer above it that does know what's going on across the clusters.
Yeah, I was just echoing that. I agree with the model. So
yeah.
And given that the Trident instances in different clusters don't talk to each other, the CRs that are on both sides, they get manually manipulated, right? And it's the job of the admin to, watch the status on one side and do the right action on the other side. Like, do we report the status of mirroring, let's say on the source, so that, the admin knows let's say the mirroring is done, and would take the right actions on, to make, for example, the secondary a primary, or do something on the destination? Like, do we have enough?
So I can't answer that off the top of my head. I suspect that no, that the source side probably doesn't receive any status updates, because again, Trident doesn't. Trident's not a monitoring tool. It's not watching what's going on. It's only responding to requests. So we have Kubernetes API watchers. So whenever any Kubernetes API object changes, we will try to reconcile its state. But we're not going back to the storage controller and like checking what's going on any kind of regular basis. We only try to affect state changes that a user has asked for, and then any monitoring has to occur separately.
Okay. I mean, ideally, I think Trident can talk to SnapMirror and get a status of a relationship, or the last transfer, and and signal to the customer that this operation is done at least, and then they can do whatever they want on the second cluster.
When something has been requested, then Trident will. So when you create the secondary mirror object, we will keep updating the status until we see that the mirror relationship is established. Once it's been established, we stop paying attention, because we say, well, we did what we were supposed to do. And then only when someone says, I want to break it, does Trident wake up and start doing things again. And everything else just happens in the background. And I don't think you
basically would get, like, as far as Trident is concerned, we don't, like, Trident doesn't treat or doesn't really track individual transfers. It basically sets up the relationship and then forgets about it, doesn't really monitor their status. It's just sets up the relationship, this replication schedule does its job, and then it's really up to the admin to track when the last transfer happened from primary to secondary, and manipulate the CRs on both sides accordingly, right?
Well, I mean, you don't need to manipulate them until you want to affect another change. Like,
let's say if you want to do like a plan failover, or if you want to do break the relationship, then you have to manipulate the CRs on both sides, right?
Yes, and the reason we don't do anything in between those two times is for scaling reasons, right? We expect people to have hundreds or thousands of volumes and potentially hundreds or thousands of mirror relationships, and keeping an eye on all of those would just be brutal from a CPU and network usage perspective. So we just don't do it. We figure if someone wants to be monitoring it, then they would use a purpose-built monitoring tool that is designed to scale in that way.
So failover will be manual, right? So someone have to
at the Trident layer, it's manual. Now the layer above Trident is able to orchestrate all of this for you, and set up a volume on one side, set up a mirror relationship on the other side, pay attention to them, automatically fail them over. Like that can be automated at a higher layer. But if you're just using Trident, yes, it would be manual.
That the Astra layer does that?
Astra will do that. I don't know if it does it today.
Okay.
I'm not an expert on exactly what Astra does and doesn't do. But it is the place where that kind of functionality would land. Yes.
Okay.
Is there a Trident mirror resource on the primary as well? You seem to be referring to the Trident mirror resource exclusively on the secondary.
So you need to create it on the primary to obtain the internal name, because that is something that an ordinary Kubernetes user wouldn't know. And so when you wouldn't be able to tell the secondary what the actual name of the volume is unless you have a Trident mirror relationship where the Trident will then put it in the status so you can see it. And it's not a particularly secret detail. It's just the kind of detail that an ordinary Kubernetes user doesn't need to know, so it's not exposed. So you create the Trident mirror relationship on the primary. We fill in the status with those details you're going to need on the secondary side, and then you fill them in on the secondary side. And then the benefit is then if you do ever experience a failover and you want to reverse the relationship and go point it back at the original one, like you already have a Trident mirror relationship object bound to your PVC, and you just have to fill in you just have to say, resync this please, and we do it. So there's no harm in creating the object immediately.
Broadly, from a model perspective, I mean, because I was talking about the volume replication CRD as such, right? The Trident mirror object is close to equivalent to what we look at. So that's why I know you said there's a lot of commonality, or you see commonality here, and so I at this level I agree, because it's the same thing. It's the volume replication object is bound to a PVC. There is one on the primary, there is one on the secondary. I did say that right now we do static PVs, but we don't want to do that. The idea is to fill the volume replication object on the secondary from a status report of the primary, which is equivalent to the mirror object that you're talking about, and then use those objects to flip state, resync, do what you want with the volume. Yeah. So broadly similar, except at Ceph we have the notion that when you establish mirroring on one end, we actually get the same underlying. The target doesn't need an image created to actually replicate to. It auto creates the image based on what the primary is. So we don't have to hydrate a PVC on the secondary before we establish replication. We can create a PVC using a data source as the wall rep, or yeah, sorry, go ahead.
I'll tell you one of the reasons we decided to have an actual PVC on the secondary, and it's because a given Trident can manage multiple storage devices and multiple sort of, we have we call them SVMs, storage virtual machines within a storage device, and when you're setting up a mirror relationship, there is a scheduling step, because the mirror relationship could go to any one of multiple devices. And so by creating a PVC, it allows the Trident scheduler to pick a place to put your destination volume out of the many potential places to put it. So and it can look at, it can look at size, it can look at performance characteristics, it can look at which devices have been peered to the primary. That's actually, it's able to figure that out automatically. So if you have two different potential devices, but only one of them has a peer relationship to the source, it will pick the one that has the peer. You might want to be able to control whether you're mirroring to slow spinning disks or fast flash or really fast NVMe. Those types of considerations all go through the Trident scheduler. So Trident picks a place to put your secondary. And so it was really easy to just say, you know what, just create a PVC. It's going to be your volume. Let it run through the scheduler. Let it apply the various filters to make sure it doesn't go to the wrong place. And then once the volume exists, then set up the mirror relationship. And once we've gone through that, we may as well just keep the PVC around, even though you can't actually use it. That's the one weird thing is you have a PVC, but if you attach a pod to it, all your writes are going to fail because it's not a writable PVC. That's the only weird artifact of the way that we do it. And so you just have to be aware that some of your PVCs are not actually writable because they're the destinations of mirror relationships.
Understood. The snapshots created on the primary are user snapshots, or in other words, Kubernetes snapshots, or is it scheduled snapshots by the storage? Or
both. Yeah, it's both. Every one the user creates will of course be there, and the storage is also creating its own snapshots on a schedule that Kubernetes is unaware of, but they're all down there. And again, that's for scaling reasons, right? If you have thousands of volumes and they're taking snapshots every 5 minutes, you don't want that many Kubernetes snapshot objects, right? You want Kubernetes to be unaware of all of those snapshots because it's just too many.
Agreed. In Ceph, we do the same thing actually. RBD or Ceph, either the block or file system. There is scheduled internal snapshots, nothing to do with Kubernetes. Those are mirrored, and our user snapshots are mirrored as well. So it's pretty much a similar scheme in that sense. Yeah, the only, like I said, the only, not the only broad level 5,000 feet delta that I see is the notion of the secondary PVC existing and the mirror relationship created out of it. But yeah, that's, I guess, detail we can.
Well, and the other place where that came in handy in our design was when you're when you break a relationship, the primary still exists, right? It doesn't go away. It's still writable. It's still a volume, and the secondary becomes writable when you have a broken relationship. And then when you want to resync a mirror relationship in the opposite direction, because you already have a PVC on both sides, it makes it really easy to say, okay, we'll just point them at each other, and boom, the relationship gets reestablished. So you're never having to delete and recreate PVCs in this model. The PVCs are just, every volume that exists has a PVC associated with it. Some of the PVCs are special because they're destinations, but that fact can change, depending on the state of the volume, and Kubernetes doesn't need to know about those particular changes. So we just say everything is a PVC. There was an earlier version of this design where we tried very hard to avoid that, but then it ended up in needing to create and delete PVCs all the time, and it got to be very hard to manage, because there were certain workflows where you needed to delete a PVC that contained valuable data so that Kubernetes would just forget about it. But internally we didn't actually delete it, and we decided that was too scary for real users to just delete their PVCs, and knowing that we're not actually going to delete them, because they're always going to wonder, well, what if we screw up and do delete it? So we're like, you know what, we're never going to delete a PVC that you don't actually want to delete. We're just everything is going to be a PVC, and then you'll only delete them when you're really done with them. And that was the design we settled on.
The one thing about not requiring target PVCs from the design that we were looking at was we could just work on the primary, and a new PVC comes into existence on the primary, everything's set up on the primary, and only on a failover or a relocation, failback or relocate, targeted failover requires the PVC to appear on the target secondary instance.
Right. Yeah, you don't need it until you actually have a failover situation. But then the question is, what do you want to do when you want to fail back? And there's the question of how do you control the scheduling of the secondaries? Like we could have had a special scheduling engine that didn't, that wasn't working on PVCs, but just working on some other sort of concept of a secondary volume. But after we looked at that, we realized it's exactly the same. It's going to be a PVC at the end of the day. So we said, well, let's go ahead and make it a PVC from the beginning.
Okay.
The name of the PVC on the destination cluster, is that something customers pick, or is that something you try to?
Yeah. Well, PVCs are always, the name only appears in Kubernetes, right? The name never gets reflected into the cluster. The actual object inside the storage device is some UUID name, chosen by Kubernetes. So yeah, the names are all, Kubernetes only labels for objects with random names. And we don't care. Now, sometimes that irritates end users who are like, why are all my volumes named these weird UUID names? I say, well, that's the price of automation.
Sorry, like the reason I talk about PVC names in the destination clusters because, you most likely want to resurrect your application in the second cluster, right? And so for your application to start, you should point to specific PVCs, right? So like that's why I asked, those PVCs should be, the names should be at least customer control.
Yeah, you can name it exactly what you want, so the primary and secondary can have exactly the same name.
Exact same name, so the same application. Cool.
And in case it wasn't obvious, like you can mirror from the Kubernetes cluster back to the exact same Kubernetes cluster, just with two different PVCs in the same namespace or two different PVCs in different namespaces. Trident doesn't care. In fact, Trident doesn't even realize that it is the source and the destination of the same relationship in that case, because it's just, it has its source side code and it has its destination side code, and they just both run. And if they're both running on the same cluster, it just works. And Trident is unaware of it. So that's another nice symmetry that came out of the design, was that because the higher level is required to do all the copying of the labels from one side to the other, Trident never needs to know if it's talking to itself or if it's talking to a foreign entity.
What about the application running there? Like on the secondary cluster, you have pods, stateful set running there, or it's only the PVCs?
So Trident is only going to handle your PVCs. Like your application, if you want to replicate your application, then that's becomes a user responsibility or the responsibility of a higher level software like an Astra. Trident does not know anything about your pods. And again, that's an intentional design decision. That Trident just does the storage in one cluster, and anything else is someone else's responsibility.
Okay.
Have you seen any issues with attaching pods on the other side? User, you have a PVC on the secondary side, which looks like it can be read and written, and pods start, but pods, the writes actually fail.
Correct.
How do you deal with that issue?
The way you deal with it is you don't start the pod until the volume is writable, and then again, that's a responsibility of the end user or the higher level software that's automating the process to basically watch the mirror relationship, observe when it becomes broken, and then create the pod. So that is an undesirable detail. It would be nice if the system could do that magically for you, but we weren't able to figure out a way to sort of have a PVC that is not attachable until an event occurs.
Right. So in the model that Shyam described, right? If I have a controller, a sidecar that can automatically protect PVCs that are labeled with a certain, label, then without any orchestration software that is required to copy this cookie from one side to another side, that model is able to enable replication just on the primary without going and doing anything on the secondary. Right. Whereas in the model that you described, Ben, to do anything, to get the replication initiated, we need to go do across the two clusters. And so I'm worried about, how does that work when, in a stateful set, I scale up the stateful set, right? Then I need to immediately go do scale up on the other side to create the second PVC on the remote cluster. Can you talk about that? How do you see that working?
Yeah, you're correct. If you were using a stateful set, you could create Trident mirror relationships for every PVC in your stateful set, but as new ones were created, like something would have to notice that, and someone would have to respond to it and create the Trident mirror relationship, and then something would have to create a secondary volume, and yeah, it would have to be other controllers that are watching for those events. So the Trident mirror relationship doesn't work gracefully with something like a stateful set where PVCs just pop out automatically as the stateful set scales. You would have to have additional controllers and additional automation to help in that situation. But something is always going to have to do the work of scheduling the secondary volume and establishing the relationship. And in I think the model that Shyam described, they're the primaries doing all of the work. We decided to only have the primary do 10% of the work and have the secondary do the other 90%. Just as I guess that was our design decision. So yeah, there are certain downsides to that for sure. That requires something.
I think it's an artifact. It's an artifact of how the replication engine works. Some storage systems, there has to be a handshake between primary and secondary for replication to happen. So it's not primarily source driven.
We could have made Trident reach out and talk to the secondary, but it just would have made the architecture dramatically more complicated in a multi-cluster environment where you have 10 different Kubernetes clusters and 10 different storage controllers, and they're all replicating to each other. Like, you begin to have question of like, well, who is responsible for the storage, right? If each Trident can talk to all of the storages of all of the clusters and create volumes on all of them, then like, where is the brain? We didn't want to have that problem. We wanted to say, you know, Trident is responsible for the storage that you delegate to it. And if you want to mirror to some other storage, someone else is responsible for that. And if you want to automate all of that, you need something higher, right? You need to have one brain somewhere that is consistent with itself, because 10 different Tridents will never be consistent with each other, just because of the nature of distributed systems. So we didn't want to create a situation where you had a distributed brain, you know, that could potentially be fighting with itself.
Right. I don't think in the Shams model that he described, the equivalent of Trident is responsible for creating the secondary volume. I think it is the storage system.
Okay.
That's responsible for creating the secondary volume. Did I get that right, Sham?
Yes, that's correct. The thing though is not all storage is equal.
Yes.
So there are storage systems out there, without naming them, which require the target volume to be set up on the secondary controller and then establish mirror from the primary controller. Now the deal there was, yes, the drivers would hence communicate across each other and set this up. The control plane will on the secondary is reachable from the primary, and so it'll set it up, which is exactly what Ben's also talking about, and scaling it out and saying, hey, if I have 10 cube clusters and 10 different storage control planes or storage clusters, then yeah, it gets a little messy.
Well, maybe I missed this one from Ben's model. You don't have to create a volume on the secondary side. I thought or you just need the snapshot to be there, but then what does that PVC points to? Does it point to some volume handle? Does the PV on the secondary side point to your volume handle as well? Or
are you asking about the Trident model or Sham's
Trident
model?
I was just I thought yours is similar, but Sham was saying it's different. So you also not requiring the PVC?
In the Trident model, you create a PVC and it goes to the scheduler.
But the PVC is empty, or is the PVC has a PV underneath, right? And the volume handle.
No, it's empty. Yeah, it's a new empty. Now it has to have you have to have a Trident mirror relationship created beforehand.
Okay,
and you need to
what does that? But okay, so is that bind? Is that like a
bind? Yeah. So you would create the Trident mirror relationship. You give it a name. You create your PVC, and you would annotate the PVC with the TMR name. Okay. And then Trident would see that at provisioning time and say, this is not actually an empty volume. This is a volume that's going to be the destination of a mirror relationship.
Then you don't really kind of skip the provisioning part?
No, it runs through the scheduler. It finds a place to put it that has the right space, the right performance characteristics, the right peer relationships, all of that stuff. And it does create an empty volume, but then it immediately makes it read-only and establishes a mirror relationship to that volume. So in the NetApp world, the way you set up a mirror relationship is you have two volumes and then you mirror one to the other. And
maybe I missed something.
The act of creating the mirror relationship destroys whatever data was on the secondary. That's just how it works.
Okay, something. So it's like in both cases, you have to have a volume on primary and a volume on secondary. Then you establish the relationship. Or is that? Am I wrong? The sequence.
Yeah.
Is that right? You create a volume on primary, and then you create a volume on the secondary, and then you establish the mirror relationship. Is that right?
Internally, yes, that is how it works. But from a Trident workflow perspective, you would create the secondary and the mirror relationship at the same time.
Oh, okay. All right, I see. But
because Trident needs to know that the purpose of this new volume is to be the destination of mirror relationship.
Okay. So it's a little different.
So it can apply the additional scheduling filters, like it has to be in a peer relationship with the primary, it has to support mirroring, all those other things. Because if it didn't know that, it might pick a place that can't be a mirror relationship or can't talk to the primary.
So Sham, in your case, the two volumes are created separately, like two steps, and then the third step is to establish the mirror?
So the Ceph works, it's kind of the storage layer. So Ceph works a little differently. So the moment you enable mirroring on an image or a volume, the two or NCEF clusters are kind of talking to each other. I mean, there are mirror processes running in these storage layers, which kind of
right. But
talk
do
to
you
each other.
I mean the what? Okay, I was just wondering, like, when do you create the volume? When does the second volume get created and get mirrored?
Second volume at the storage level layer gets created when mirroring is enabled on the primary, right? So because
okay,
the second volume on the
so it's
Kubernetes
similar
resource,
then, just like once. So you first create a primary volume on the primary side, and then you basically establish the mirror relationship on the secondary side, and then you will automatically create the.
I think the main difference is, you're using the term volume, but I think we may want to talk about the terms PVC, PV, and the storage volume. Then I think
I'm talking about the storage volume. I'm talking about the storage volume. So kind of get what Ben was saying, because the one that I'm familiar with is normally you have to create a volume on one side and the secondary side, then you establish the relationship. So I was just wondering the slight difference in, I mean, storage systems are different. So I was just wondering in the Sean's case.
That's correct.
It's the same as Ben's, or is the same as what I said, like almost like 3 steps.
No, it's not. It's like you create the storage volume on the primary, and then you have to mirror enable it. I mean, that's step 2. You say, mirror enable this volume. The volume on the secondary is auto created.
Okay, so it's okay, but I think that's similar to what Ben's. Okay.
No. Well, the difference there is that one CSI driver is creating both of the volumes, and it's the one that's on the primary. So a PVC gets
sorry, I was
creates a
more
PV
thinking about
and
the
it creates the secondary too.
Sorry,
automatically.
I'm more, I was just trying to understand the underlying APIs, like how many APIs you need to call to get there. So maybe that's too much details to talk here.
Okay. Just one clarification on what Ben said. So Ben, CSI driver in this case is not creating the volume at the remote secondary. The storage layer mirroring processes are the ones that are creating the volumes on the secondary. CSI is not involved.
CSI driver,
that's just how Ceph is built.
CSI driver will be making one call, right? Like the call your storage system. So
the storage system knows how to talk to the other storage system and just make things happen.
That's correct.
Yeah.
So one thing in Ben's model that caught my attention is the fact that we established on the secondary, the volumes provisioned empty read-only based on an annotation on the PVC, which you have to communicate data somehow, so that's fine. Yeah, I was more tempted to, because now we have any data source, I was more tempted to say, hey, the secondary could be a PVC within any data source of Trident mirror object or volume replication object, and that carries the cookie information so that we don't poke back at the annotation. But that's again 1 year back.
I hate using annotations for real data, but it's a common pattern in Kubernetes, unfortunately, because we can't just add a new field to the PVC, which is what we would prefer. We'd prefer to have another spec field that we could just fill in with this information, but that's not going to happen.
I agree. A year back, I would have done the same thing. I mean, I'm just saying, just because we have any data source, any volume source, we have options now, not 6 months back.
Oh, well, yeah. So as far as volume populators are concerned, yes, like you can create new volumes from things, and we certainly have thought through, various types of cloning use cases. But it turns out that because we already have a PVC that's just sitting there that is the destination, we don't need to do anything special, right? Like PVC cloning is already a thing in Kubernetes, so you can just you can create a volume that is a clone of the destination of the mirror relationship by just doing ordinary PVC cloning, and it just works. Because Trident understands what you meant when you pointed a new PVC at the old PVC, and it says it doesn't care that it's the destination of a mirror relationship. It's just something that is going to clone, so it just does it, and then you get your new volume. So that's the way to get a writable copy of the destination without breaking the mirroring relationship, because then the mirror destination is still receiving writes, and you've just cloned it to create your own writable copy of it at a particular point in time. That's totally valid.
I was more looking at volume populator during provisioning time for the secondary PVC, saying PVC with a volume populator of
okay.
Trident mirror object, which says, oh, okay, so you need this mirror object, and that's a secondary, so I'll create an empty volume for you, read only, etc., and then just,
yeah,
it's just avoiding the annotation. That's
but the weird thing that we observed after playing with this for a while was, these mirror objects sort of are permanently related to the volume. As long as the volume is involved in any mirror relationship with any other volume, it's going to have the sort of sidecar CR sitting there, expressing the mirroring state of that volume. And you could detach a volume from one mirror relationship and attach it to a different mirror relationship, and it can switch back and forth between being a destination and being a source. And it's just it's all very symmetrical. And so we didn't want to create a situation where the source looked different from the destination in any sort of long-term way, because we knew that it could tomorrow it could be flipped backwards, and we didn't want that to look weird. So we make everything look perfectly symmetrical. You have volumes and you have mirror relationship objects, and it looks the same on the source and the destination, other than that one says it's the source and one says it's the destination currently, but those two values can flip whenever you want them to.
Quick question on that. On the primary, when you create the PVC, you still have the annotation pointing to a Trident mirror object?
You don't have to. So that's the fun part, is you can create an ordinary PVC with no TMR and then start using it for a while, and then later you can decide you want to mirror that volume, and at that time you can go create your TMR, bind it to the PVC by creating an annotation at that time, and at that point it becomes, and as long as it was on a system that could be mirrored, then you can just start mirroring it. Of course, you could get unlucky and it could have gotten scheduled to a system that doesn't support mirroring or isn't peered to the system you want to use or whatever, in which case you're out of luck. But if you got lucky and the original volume ended up in a place that can be mirrored from, then yes, you can decide to mirror it long after it was originally created by just creating the TMR object at that time.
I'm sorry, yeah.
Got it.
Top of the hour. So Ben, you want to prepare some slides next time, and then you can continue?
I can't promise in 2 weeks. I mean, I will make the slides. I promise I will make the slides.
Okay.
I can't promise it'll be 2 weeks from now, because I have all my volume populators work to get done before the end of the month.
Okay. Yeah, that one we give you a deadline. Okay, so that
Yes.
one. So okay, I will check with you maybe by the end of the week, or you think maybe next week. Well, I will check with you in a few days.
Yeah.
Just see how you're doing with that.
Okay.
All right.
I hope this was helpful. Sorry I don't have visual aids to go along with my talking.
No, that's fine. I think it's helpful. Yeah, I think this is a complicated topic, so yeah, so it's good that we started talking about it. Okay.
I believe we understood you, Ben. Thank you.
Okay.
Yeah. Okay. Thanks, everyone. Bye.
Thank you.
Thank you.